Hey, what's up, fellas? What we're looking at right here is a 2 megawatt surface mix oxygen lance burner. We're going to be running diesel today. And today we're working for Damingo over in Venezuela. He has commissioned 2 of these burners, and on his behalf I've built a third one so that these tests can be conducted in order to zero them in by the time these systems arrive at his concrete plant. This was just a little test right out in the middle of things when we were out of oxygen. We do eventually hit 2 megawatts. This is a beautiful picture of his factory, and man, look at the sky in Venezuela. They chemtrail us to death here, so we don't get skies like that anymore. But this is what they were testing out. They did a first initial test with some burners they had available at the time, and they wanted to do something a little more significant, and they wanted higher temperatures, so we're going to help them out. Okay, Damingo, this is kind of a breakdown of the 3 connections to this system. We have the bottom connection, which is the air, and that connects to this air plenum. This is just a big tube. The fuel will come out of the center there. The air comes out of the annular orifice. The fuel comes in through this center rail. These are all 1/4 inch NPT. This will not be on there. This is not what you guys are going to use. You're going to want to connect this with a 1/4 inch MIP. And essentially what I've seen in testing today shows that we're going to want about 160 psi's of oxygen going through these lines. Might be able to get away with less because I have these very small constrictions here. If we avoid small constrictions like this, the pressure would be drastically reduced. Okay, we're getting set up for the test here. This is what we have. We got our fuel raised up. We got the ground wetted down because we're about to burn this grass, that's for sure. The first test we're going to do is a flow rate test. I'm just going to open the valve to the fuel tank and we're going to register the fuel reading and see if we got enough head pressure on this thing. We got to hit a minimum of 2 liters per minute. So here goes. I think, I'll have to double check that math. Pretty sure we were going for 2 liters per minute on our test. I'm going to go ahead and stop that there. Okay. We got some serious air here. I gotta hurry. We'll lose that other compressor. I think it already kicked off, so when it goes to kick back on, it likes to die on me. Okay, here goes. Dude, that's a lot of air, boys. We're gonna let that normalize. All right, somehow I lost the footage of it, but I did put this meter in front of this burner. It has an 85 millimeter opening, and we hit 35 meters per second on the discharge rate. So it was pumping a substantial amount of air. we got a lot of wind blowing in this direction, messing us up here. All right, we got both engines running. We're ready to roll here. We're gonna do a 2 megawatt test with oxygen injection. So that's where we are on oxygen, down to about 520 pounds or something. We're gonna let this cool off, and we're gonna put it inside the air cowling now. So it looks like 120 PSI is about the max you're gonna want to get to this. I'll go check those back pressures again, but both compressors did manage to stay running during the test. The problem with this compressor is that it's just too gnarly. The gear ratio I have on this thing is absurd. The pulley that came on here was about this big around, meaning the belt dipped down in there about this far. So you're looking at, you know, that much advance. So that alone has overclocked this thing beyond what the engine can almost handle. What happens is once it reaches pressure and shuts off, there's not enough momentum to kick the compressor back on when the unloader kicks back. So when that unloader kicks back on, there's not enough momentum and the ratio is too high here. Too many RPMs, too little torque. Okay, now we are ready for the secondary air test. Fortunately, we only have 500 PSIs of oxygen left. We got a little carried away there, and we got about a half tank of fuel. Well, maybe not even that much. We need to achieve 3.3 liters this time. So we need to be up in here. We were only hitting 2. Hopefully we have enough head pressure. I may have to raise that tank up higher. gonna kill it. So we did not have enough head pressure. I'm gonna measure that and see what it was. I know for a fact we can hit 4 megawatts on that thing. We just didn't have the fuel pressure we needed. We were at about 2.2 liters per minute, maybe 2.5 liters per minute. So almost where we wanted to be. We would have to raise that tank. I went ahead and shut it down. It's getting too hot. We lost that other air compressor again. All right, so we currently have about 4 foot of head, which just ain't quite enough. So I'm thinking about, I don't really want to lower the burner. That would give us another foot if I lay that on its side, but we definitely need to try and raise that fuel tank up. And because we're at the bottom of the fuel tank, we lost a little bit of pressure head from that alone. So if we were at the top end of that tank, we might have got a little bit more flow. I think we need to try this one more time and increase the pressure just a bit. Right there underneath it. We've got room to go up a little higher there. Getting a little risky. I'm going to blow up all my hoses. Okay. All right, this just got really dangerous. I got pressurized fuel lines now. Turn this on. That's your 2 megawatts right there. I'm gonna shut it down. It's getting too hot. All right, so I had the pressure set on this air compressor at about 4 PSIs. Had I turned it up just a little bit more, we would have been able to get that 3.3 liters. I think we got real close enough to call it for the day. I'm about $30 in the hole on diesel, and I'm out of time. So we got to end it here. I'm going to call it a success as far as we obviously can hit that 0.1 liter per minute with a little more pressure on that tank. I just didn't want to overpressure those fuel lines and have one of them burst during operation. So I was playing it safe. I should have just hit it with like 10 psi's. We probably would have been okay. And that would have gave us the head pressure we need. But this test did show us that if we're going to raise the tanks above the burner, they're going to have to be about 7 feet in the air to overcome the resistance of all the plumbing. I would imagine that the gauge itself was probably robbing me of that 0.1 liter per minute. So there you have it, Damingo. The most important aspect of this is your ignition. You guys can use electric spark ignition, but what you're going to want to do is start off on very low air. You don't want any secondary air on at all, or tertiary air, I should say. All you want is very low air compressor air and moderate to high fuel for ignition. I recommend you set the burners up on a stand like I did and have your operator mess around with them for an hour or two and become accustomed with their performance and their behavior or whatever characteristics he may need to learn. That's where it's going to be figured out the best. It's just a quick bench test. So the only reason why I'm not being adamant about running the test again to proof the 2 megawatts is because I have footage, and I've got a video about 4 years old of a similar burner, the exact same kind without the oxygen lance, pushing 4 megawatts. So we have that burner doing 4 megawatts on file already. There's no need to waste a bunch of gas. I got close. We got it at a minimum to 3.1 liters per minute. And I believe the flow gauge itself was robbing me of that last little bit. So I'm not going to stress it. I'm about $100 in the hole on this test. We're not running that thing again. It's very expensive. So maybe I'll put the price per hour on there. But that's what I got. Damingo, let me know if you have any problems. We'll get you down the road.